So when we do this sort of things, we're just normally using the standard rules for arithmetic, things like the distributive law, the associative law, the commutative law, the general laws of math. And let's think about, or general laws of this kind of algebra. Let's think about what happens if we try to multiply some polynomials. So let's pick some easy polynomials. Let's take 2x squared, and I want to take 2x squared times the polynomial, let's say, negative x cubed minus 7x plus 1. Okay, we'll be a little more adventurous. So I want to take this polynomial times this polynomial. This happens to be a monomial, this happens to be a trinomial, that's fine, whatever. We don't care, we just want to multiply two polynomials. Okay, well, I know that in general, whenever I have something of the form a times b plus c, I can take ab plus ac, whatever these are. So I have this times this plus this plus this. So what can I do? Well, I can take 2x squared times minus x cubed plus 2x squared times minus 7x plus 2x squared times 1. Okay, so what do I get here? Well, here I get minus 2x to the fifth. Here I get minus 14x cubed. And here I get 2x squared, which I can write as minus 2x to the fifth minus 14x cubed plus 2x squared. Now, some of you might get scared. You might say, wait a second, Professor, you did this part really quick. I have some exponents, a 2 and a 3, and I don't know what to do. Do I add them? Do I subtract them? Do I multiply them? You quickly jump to addition here. Well, let's think about this for a second. Just as a refresher, if you have x2, x to the squared, or x squared, or x to the 2, times x cubed, what does that mean? Well, that means I have 2x's there and 3x's there. So it is just x times x times x times x times x, which is x to the fifth. Now, you probably didn't forget that, but in case some of you did, whenever you're worried about trying to figure out whether it's multiplication or addition of these exponents, well, you can always go back to the definition. Think about what x squared really means. Think about what x cubed really means. And if you remember what x cubed means and you remember what x squared means, you can't get that part wrong. You know that the coefficient has to be 5 in this situation. Okay, but maybe we want to multiply something else. So let's try to multiply two other polynomials. Let's do sort of a simple example. Let's try x squared minus 8 times 2x minus 3. Okay, so maybe a little more complicated than the last one because we don't just have one monomial. We have a binomial right here that we're multiplying. So a lot of people might have heard somewhere that they're supposed to do first, outer, inner, last, right? FOIL. And you can do that. You can take the first two terms and the rest. But what are we really talking about here? Well, as long as we multiply everything here times everything here, it really doesn't matter what the order is. So I need to take this. I need to take this. I need to take this. And I'm running out of room here. I need to take this. So each of these two terms have to multiply each of these two terms. And what do I get? I get 2x cubed plus minus 3x squared minus 16x. And then I get, well, minus 8 times minus 3 gives me a positive 24. And that's my answer. But notice it really doesn't matter which order I do these for. At the end, I might want to regroup things so the highest coefficient is on the left. But I would always get the same answer, no matter which order I chose in order to do each of these individual multiplications. So those are some examples of multiplying polynomials. Obviously, it might get more confusing if I wanted to multiply some trinomials. Then I might have, say, let's do one with simple coefficients. We'll make those 1, and we'll make these x3 minus x squared plus x. Okay, well, now, okay, I could do what I did last time and remember to multiply each of these with each of these. So I have to multiply this times 3 things, this times 3 things, this times 3 things. Well, you know what I could do? I could make my life a little easier by just basically doing an intermediate step. I could say, okay, this is going to be x squared times this whole thing on the right, plus x times this whole thing on the right, plus 1 times this whole thing on the right. And then I can do each of these individually. You might say, well, this is kind of long. Yeah, it is a little long. Sometimes things are long. We just have to deal with it. Nothing in it is particularly hard. Each step is simple. We just have to make sure we don't mess up. So what do we get here? Well, we have one term of x to the 5th, and then we have this minus x4 and this plus x4. So those are going to cancel each other out. And we have this plus x3 and this minus x3, or x to the 3 and minus x to the 3. So what do we have here? Well, we have 1 plus x to the 3, or x to the 3rd power left. These two go away because this is a plus and a minus. They cancel. So what do we have here? We just have a plus x. And that's our answer. So yes, I could try to do it all in my head by taking 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I could write out an intermediate step using the distributive law, distributing each of these to the term on the right, or I could have distributed each of these things to the term on the left. Either way would have been fine.